In the last lecture, we have seen some examples, actually some formulas we have proved for the nth derivative. Now we'll try to go further and we'll try to see how the product of exponential function and trigonometric functions, okay, or how to find out with the nth derivative when we have a product of the trigonometric function and exponential function. Okay. Are you able to see this journal page?
Yes, sir.
Yes, sir.
Okay, that's great. Okay, so suppose we have y is equal to e raised to ax into cos of dx plus c. Okay, so we have y is equal to e raised to ax into cos of dx plus c, and then we want to find the nth derivative of this. Okay, so what we do, we differentiate. Okay, so differentiating y with respect to x, we get. So what we are able to get here, see, we'll have the first derivative. Here we have to use u into p. Okay, so what is derivative of u into p? It is u as it is derivative of v plus v as it is derivative of u, right? So this is the rule we have for the derivative of the product of two functions. Now this is one function and this is the other function. So let us keep this function as it is. So this is cos of dx plus c, and have the derivative of this function. So we know now what is the derivative of e raised to ax. It is a into e raised to ax. Now plus, so this e raised to x remains as it is, and the derivative of this cosine. So what is the derivative of cosine? It is going to be minus sine bx plus c, and here we have into the derivative of this bx plus c, that is going to be b. Is that okay? Are you able to get this one?
Yes, sir.
Yes, sir.
So what I can do is I can have this e raised to ax common, and then I can write this as a times cos of dx plus c minus b times sine of dx plus c. Is that okay?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So now let us see one triangle. Okay. So suppose I have a right angle, okay, and this angle is going to be, okay. So this angle is going to be, this side is going to be B, this side is going to be A. This is a right angle triangle. What will be the hypotenuse?
Under root a square.
Under root a square plus b square.
plus b square.
Very good. Okay. What will be tan inverse of phi? Sorry, what will be phi?
Tan inverse of b by a.
Tan inverse of
b by a.
Correct. Okay. So hypotenuse is going to be square root of a square plus b square, and phi is going to be tan inverse of b by a. Okay. What if I divide this expression and multiply this expression by r? So I'll be having y1 is equal to r times e raised to x. This is cos of dx plus c into, this is a by r minus sine of Ax plus C into E by R. Okay. So considering the geometry of this triangle, okay, what we can have, what will be B by R and what will be A by R?
E by R will be
Sine phi and cos phi.
Sine
sorry,
Sine
going to
phi
be
and
phi and
cos phi.
cos phi.
cos phi.
Yes. So it is going to be sine phi and cos phi.
Cos phi.
Yeah. So we replace these terms here and hence we can have R e raised to ax. So we can have cos of bx plus c and this is going to be cos phi minus sine of bx plus c and this is going to be sine of phi. Okay. So what we know about this formula? Okay. So what do we have? Cos of a plus b. So it is cos a cos b minus sine a sine b. So look at the terms what we have. Okay. So can you see this? It is cos of bx plus c into cos phi and this is minus sine of bx into sine phi. So
Phi and bx plus.
yes. So can we write it as r e raised to ax and this is going to be
Cos of bx plus c plus phi.
yes. So it is going to be cos of bx plus c
Plus c plus phi.
correct.
Phi.
Okay. Yes. Okay. So we can write this as is going to be cos of bx plus c plus phi. Okay. This we got as y1. Okay. What I can do is I can again differentiate this. Okay. So again differentiating above equation B gate. Okay, so what we'll have? We'll have y2, and this is r. This is e raised to ax. This is a cos of bx plus c plus phi minus b sine of bx plus c plus phi. Is that okay? What I did is I have taken this r is going to be constant. So e raised to x I have taken out. And so the derivative of e raised to x is a into e raised to x. So this a is here. The derivative of cosine is again b sine of bx plus c with the minus sign plus phi. And this e raised to x I have taken again. So what I can do is I can again multiply and divide by r. So we can have r time r again we are taking r, so it will become r square. So it will be cos of bx plus c plus phi into what you will be having a by r, and this is minus. So we can have sine of bx plus c plus phi and into b by r. So we can have this as r square e raised to ax. This is cos of bx plus c plus phi, and this is cos of phi minus sine of bx plus c plus phi, and this is sine of phi. So can we write this y2 as r square e raised to ax cos of bx plus c plus 2 phi?
Yes, sir.
Yes, sir.
Here it is. Yeah, so again I'm using the same formula. So cos A cos B minus sin A sin B. And so we get it as cos A plus B. Okay. So now we got the first order derivative here. Okay. This is the first order derivative we have. Okay. Now we can say where r is equal to square root of a square plus b square, and theta is tan inverse of b by a. And we got the second order derivative here. Okay. So this is the second order derivative we have. Okay. Now, if we have the first order derivative and we have the second order derivative, now we can go for the next. So what we have to do is, again, we have to differentiate. Again, differentiating of equation we get. So what we are able to get? By 3. So we have r square, and this is e raised to ax a cos of bx plus c plus 2 phi minus you'll be having b and sine of bx plus c plus 2 phi. Okay, so what we do? What we have to do now?
Same thing, multiply, divide by r.
Multiply and divide by r. So we get r cube e raised to ax cos of bx plus c plus 2 phi, and this is a by r minus sine of bx plus c plus 2 phi, and this is b by r. So we can have r cube e raised to ax. This is cos of bx plus c plus 2 phi, and this is cos of phi minus sine of, we got here bx plus c plus 2 phi, and this is sine of phi. So again, we can get this third derivative as r cube e raised to ax, and we got here this is cos of bx plus c plus we got here
C5.
this is
C5.
now yes. Okay, so here we got the third order derivative. Okay, so now tell me, is it sufficient to generalize, or shall we go for one more derivative?
It is sufficient, sir.
It is
It is
sufficient.
It is sufficient.
Very good, very good.
It
Okay,
is sufficient.
so now you got the idea how many derivatives we have to find. Okay, so if we are able to generalize the idea, then we have to stop taking derivative. If we are not able to get or we are not able to generalize the idea, then we have to go on taking the derivative and try to find out the pattern. Okay, now see what had happened. Okay, or what is happening. Okay, so when we consider the first order derivative, see the first order derivative. What we got here, e raised to x into cos bx plus c, this is our function. So we got r xy here, we got phi. If we consider the second order derivative, again we got r and we got 1 phi. Again, if we consider the third order derivative, we got r and we got phi. Okay, so what is happening actually, for every derivative we are taking, we are getting r in the multiplication and phi in the addition. Okay, so that means our magnitude is increasing by r, the factor r, and our phase difference is increasing by the angle phi. Okay, So here, if we want to generalize this, okay, so what will happen if we go on taking in this way, then in general. Okay, so what will have in general?
Y
N
yn is equal to r raised to n.
We have yn is equal to, just see this and check that you get it correct. Okay, so we get r raised to n. Okay, so number of times I am getting derivative. So yn is equal to r raised to n, and then it is e raised to ax also bx plus c plus n form. Okay. Now the thing is that r and phi are not given to us. Yeah, so these are not the term given in the expression. So that's why we have got this term. Hence, we have to mention, okay, where what is going to be r. So r is going to be square root of a square plus b square. So we got here square root of a square plus b square. Then what is going to be phi? So
Tan
and
inverse b by a.
phi is
Tan
going
inverse
to be, yes. So tan inverse of b by
B
a.
upon N.
Okay. So this is how we need to write the nth derivative. If we have all the terms as given, then we don't need to write extra. But if we have introduced some terms, then what that terms means or what is the value of that terms, that we have to write. So is there any doubt this example?
No,
No,
sir.
sir. No doubt.
No, sir.
All of you got this?
Yes, sir.
Yes, sir.
Yes, sir. Got it.
Yes. Okay, that's great. So we'll go for the another one now. Okay, so let's go for the next. Okay. Now, suppose instead of cosine, okay, we have sine. Okay, then what will happen? Okay, so let us try with sine. So we can have let y is equal to, okay, e raised to ax into sine of bx plus c. Okay, so if we have y as e raised to ax into sine of bx plus c, what we have to do is differentiate. Okay, so differentiating y with respect to x, we get, okay, what we are able to get here. See, again we have to use u into v rule. So y1 is equal to a e raised to ax, and this sine of bx plus c remains as it is, plus this e raised to ax remains as it is, and the derivative of sine is going to be cosine. So cos of bx plus c. This. Okay. Now we have y1 is equal to e raised to ax is common. So a sine of bx plus c plus b cos of bx plus c. Again, if we consider the same geometry, okay, so what we have here, this is the right angle triangle, this is phi, this is b, a, okay, this is going to be r. So what is r? Again, it is square root of a square plus b square. Then what is phi? Phi is going to be tan inverse of b by a. B by r is going to be, what b by r is going to be?
Sin phi.
Sin phi.
Sin phi. And this is
A by R is equal
Cos
to
phi.
cos phi.
Okay. Now, what we can do is we can multiply, okay, and divide by R. So R e raised to ax, and this is sine of ax plus c, and this will be a by R, plus this is cos of ax plus c, and this is going to be b by R. Okay, so that's what we'll be having here. Now we can replace these terms. So where we can have this as this is equal to R e raised to ax is going to be sine of ax plus c, and what this term is, this is cos phi, plus this is cos of ax plus c, and what this term is, this is sine. Okay, so here we have introduced r and phi, so we need to write where r is going to be square root of a square plus b square, and phi is tan inverse of b by a. Okay, so what we have now, we consider this term. Okay, so we have the formula. What is formula?
Sin
Sine
A plus B
is
is
equal
equal
to
to
sine
sin A cos B plus cos A
B
sin B.
plus cos A sin B.
yes. So this is the formula. Now here a is going to be this term ax plus c, and b is going to be phi. Okay, so we can write y1 is equal to r e raised to ax. This will be sine of, this is bx plus c plus phi. Okay, we can write y1 is equal to r e raised to ax sine of bx plus c plus phi. So this is going to be our first derivative. Okay, so we got here first derivative. Now we want the next. Okay, so what we have to do to get the next derivative? Okay, we have to go for differentiation of this first derivative. So let us differentiate again. So what we can say is, again, differentiating of equation we get. So what we are able to get is y2 is equal to r e raised to ax. So here you'll be having a, and this is sine of bx plus c plus phi. Then this is plus b cos of bx plus c plus phi. Okay, so that's what we have. Now, what we do next? We have to multiply by r and divide by r. So it will become r square e raised to ax. This will be sine of bx plus c plus phi, and here we have a by r, plus this term is going to be cos of bx plus c plus phi, and here we have b by r. Now what we can do is, we have this r square e raised to ax is going to be sine of bx plus c plus phi, and this is going to be cos of phi, plus this is cos of bx plus c plus phi, and this term is sine of phi. So can we use the same formula again?
Yes. Yes, sir.
Can we use the same formula again? Yes. So
Yes,
if
sir.
we use the same formula again,
Yes,
then we get r square e raised to ax, and this time we get the term sine of bx plus c Already we have 5. 5 will be added. So we have 2 5. And so we got the second order derivative. Yes. And now we go for the next. So again, differentiating. Of equation negate. So what we are able to get is y3 is equal to r square e raised to ax a sine of bx plus c plus 2 phi plus b cos of bx plus c plus 2 phi. Okay. Now, what we can do is, again, we multiply and divide. So we have r cube e raised to ax sine of bx plus c plus 2 phi, and this is a by r, plus here we have cos of bx plus c plus 2 phi, and this is b by r. Now we can write this as, so y3 r cube e raised to ax, this term is going to be sine of bx plus c plus 2 phi into cos of phi, and plus this is cos of bx plus c plus 2 phi, and this term is sine of phi. Can we use the same formula again?
Yes, sir.
Yes, sir.
Yes, we can use. Yeah. Okay. So we can say that y3 is equal to r cube e raised to ax and sine of bx plus c plus 3 phi. So we got here, this is the third order derivative. Now, can we generalize this?
Yes, sir.
Yes, sir. Yn.
Yes. So we can generalize this. And proceeding in this way, what we have in general, we have. Okay. So what is the term we'll be having? Yn. Okay. Yn is equal to, we got r raised to n e raised to ax sine of bx plus c plus n phi. Here r is equal to square root of a square plus b square, and y is equal to, so it's going to be tan inverse of y. So this is the nth derivative for y equal to e raised to ax into sine of bx plus c. So all of you got this?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So you got this derivatives, nth derivative of e raised to ax into cos of bx plus c and e raised to ax into sine of bx plus c. Is that okay?
Yes, sir.
Yes,
Okay.
sir.
Any doubt you have?
No, sir.
No, sir.
No, sir.
Okay. That's great. Okay. Okay. Now we'll go for the next. So we got the idea about how to find the nth derivative. What do we do usually? We find the first order derivative, we find the second order derivative, we find the third order derivative, and then we try to get the nth order derivative if possible. If we are able to get the pattern, okay, then we generalize that pattern. Okay. Now we are done with the exponential function. We are done with the trigonometric function. We are done with the product of the exponential and trigonometric. Okay. So now it comes to algebraic function. Okay. So what is or how we are able to find the nth derivative of the algebraic function? Okay. So let us try to find the product of the nth derivative of the algebraic function. So what will be having? Suppose y is equal to ax plus b bracket raised to m. So here we are assuming that this m is going to be a positive integer sufficiently large enough. Okay, so whatever the nth derivative we are finding, this m is going to be larger than this m. Okay, so m is going to be larger than n. That means the derivative exists. If m is less than n, then the derivative will be 0. Okay. So why m has to be greater than n? As I said, if n is going to be greater than m, then the derivative will be 0. Okay. So we want to find the nth order derivative of this function. Okay. Let us try. Okay. What we do in the first step?
Take
Chain
log.
rule.
Okay. Differentiate. Correct. So differentiating y with respect to x, we get. Okay. So we'll be having y1. Okay. Now it is easy. Okay. What we know is we know the derivative of x raised to n is n into x raised to n minus 1. But if you have the function, okay, that is d by dx of f of x bracket raised to n, then how it changes? It changes as n into f of x bracket raised to n minus 1 into d by dx of f of x. Okay, so this way we have to use. Now here you can see this is going to be the function of x. Okay, so what will happen here? This m, okay, this m will come down. Then you will be having x plus b bracket raised to m minus 1. And then the derivative of this term. What will be the derivative of this term?
A.
Is
Yes. So what we got here? We got the first order derivative as y1 equal to. Okay, so we got here m into a into ax plus b bracket raised to m minus 1. So are you getting this term?
Yes, sir.
It's easy.
Yes, sir.
Yes, correct. Okay. Now again differentiate this. Okay. So again differentiating of equation we get. So what will happen? Y2 is equal to m and a remains as it is. So you will be having m minus 1 will come down now, and then you will be having ax plus b bracket raised to m minus 2. And again we'll have the derivative of ax plus b. That's going to be a. So what we can write? Y2 is equal to this a and this a. So m into m minus 1 into a square. And here we have ax plus b bracket raised to m minus 2. Okay. So that's what we got here. Now this is our second order derivative. Okay. So we got the second order derivative here. Now try to get the second order derivative, third order derivative. So again, differentiating both equation we get. So what you are able to get here? This will be y3. Now m into m minus 1, and we have this e square. What will happen here? We'll get m minus 2. Then we'll have ax plus b bracket as to m minus 3, and we'll have a here. Now we can write this y3 as m into m minus 1 into m minus 2, and this is a cube. Here it remains ax plus b bracket as to m minus 3. Okay, so that's what we got here. So this is the third order derivative. Okay. Now, if we go on solving, so are you able to see the pattern, or are you able to generalize this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So if you are able to generalize, then it's okay. If you are not able to generalize, then we have to find few more derivatives. Okay. So if we proceed in this way, in general, we have, okay, so we want to find the nth derivative. Okay, now see, it is easy to guess that we'll have a raised to m, and this last term, okay, what will be having ax plus b bracket raised to m minus n.
M minus N.
Every time will the power will be reduced by 1, and then at the nth derivative the power will be reduced by n. Now we have to think of these terms. Okay, so we
M-
have m here,
N factorial upon
minus
minus n
1
factorial.
here, and so on the term. The last term that we have to think.
M minus N
M
minus
minus N.
M minus
minus 1.
M minus N.
M
N
minus
minus
N minus
N
1.
plus 1.
N plus 1 plus 1.
So are you getting this term?
Yes, sir.
Okay,
Yes, sir.
see here, because here we have 3. Okay, but we are going up to 2. Here we have 2, but we are going up to 1. Okay, so it will be m minus n plus 1.
Minus 1.
Is this okay? Plus 1 if I reduce?
Yes, sir, correct.
Or then I have to write bracket here, n minus 1 if you want to write. Okay.
M पे तो depend करता है.
So can't we write it as m factorial
want-
by
yes.
m minus n factorial?
Yes, sir.
Yes, if you want to express this in terms of factorial. Okay, now you got this one. Okay, this is okay. You got up to this one. Now, if you want to express this in terms of factorial, okay, so what we have to do? Okay, so let us try to express this in terms of factorial. So if you want in terms of factorial, what we know is m factorial is equal to m into m minus 1 factorial. Is that okay?
Yeah.
Okay, so what I can write is, I can write m as m factorial upon n minus 1 factorial. Is that okay?
Yes, sir.
Yes, sir.
This I can write as y1 is equal to m factorial into a. This is ax plus b raised to m minus 1 upon m minus 1. Are you getting this?
Yes, sir.
Yes, sir.
Okay. Now, what is the next term we have? M into m minus 1. So, continuing with this, again, m factorial is equal to m into m minus 1 into m minus 2 factorial. Is that okay? So, this term we want m into m minus 1. So, can we write m into m minus 1 as m factorial upon m minus 2 factorial? Can we write like this?
Yes, sir, we can.
Yes, sir.
Yes. Okay. So that means this term will be like this. So y2 is equal to, it will be m factorial a square. Okay. I'll remove this term. Okay. Remove this also. And this is ax plus b bracket raised to m minus 2 upon m minus 2 factorial. Okay. So we get this in terms of factorial. Now the third derivative. So what we can write here, this is equal to y3 is equal to m factorial a cube ax plus b bracket raised to m minus 3, and here we have m minus 3 factorial. Are you getting this term?
Think about it.
Yes, sir.
Yes. Okay. And then in general, okay, what we can write this as, this is y(n) is equal to m factorial a raised to n ax plus b bracket raised to m minus n. And so I can write this as m minus n factorial. Okay, this will be m minus n. So if we want to express this in terms of factorial, then this is how we are able to express this in terms of factorial. So you got this idea of expressing this product, continuous product into the factorial. Okay. Is that okay? Is there any doubt?
No, sir.
No, sir.
No, sir.
Okay. All of you got this one?
Yes, sir.
Yes.
Okay. That's good.
Yes, sir.
Yeah. So if you have any doubt, you can ask. Okay. No problem. Right. So once you are done with this algebraic, we need to think what happens to the reciprocal function. Okay. So let us try with one reciprocal function. Okay.
Minus 2 factorial and minus 2
So suppose we have y is equal to 1 upon ax plus b. Okay. This is infinitely differentiable function. Okay. So we want to find the nth derivative of this. Now, what we do is differentiate this. Okay. So differentiating y with respect to x, we get. So what we are able to get here, see, we know what is the derivative of 1 upon x. So if we consider the derivative of 1 upon x, then it is going to be
Minus 1 by x square.
minus 1 by
Minus
x.
1 by x square.
Minus 1 by x square.
Correct. Okay. So, but if it is a function 1 upon f of x. So if it is a function, then what will be having? Minus 1 upon f of x bracket square, and then we'll have d by dx of f of x. Okay. So if it is only variable, then it's okay. But if it is a function, then we have to consider this term also. Okay, so let us try. We have this. Okay, so what do we got here? Suppose we have y1, then this will be minus 1 upon ax plus b bracket square. Okay, and now the derivative of this term. So what will be the derivative of this term?
A.
A. Correct.
A.
As we have to generalize this. So we have to generalize this. So don't be in hurry. This is going to be minus 1 into a, and here we have ax plus b. Okay. So this is our first derivative. Okay. So consider this as our first derivative. Okay. Now,
Ax plus
Yes.
ax plus b whole squared.
yes, square. Okay. So consider this as our first derivative. Now we want to go for next. So what we'll do is again differentiate. Okay. So differentiating our equation with respect to x, we get. Okay. So what we have here, y1 is equal. Okay. So now we'll have square of this, and then again we'll have the derivative. Okay. So here, what I can do is I can write this y1 as, we can make it easy by writing this term as minus 1 into a, ax plus b bracket raised to minus 2. Is that okay?
Yes, sir.
Yes, sir.
Okay. So this is more easier than 1 upon x. Okay. So finding the derivative of x raised to n is more easy than finding the derivative of 1 upon x or 1 upon x raised to n. Okay. And that's why if we think this function like this, okay, so what will be the second order derivative? Minus 1 into a, this will be minus 2, ax plus b, one power will be reduced and one a will be here. Are you getting this?
Yes, sir.
But what I'm writing is y2 is equal to, this is minus 1 minus 2, and you'll be having a square, and this is ax plus b raised to minus 3. Is that okay?
Yes.
Yes.
Yes, sir.
Okay, but as we know, we have to generalize this. So what I'll do is I'll take minus 1 from here, I'll take minus 1 from here, and I can write this as minus 1 square. Okay, then what remains is, if I take minus 1 from here, I have 1 here. If I take minus 1 from here, I have 2 here. So 2 into 1, I can write it as 2 factorial. And then this term a cube remains as it is, and we have this a square. Okay, so it will become a square, and we have this is ax plus b bracket cube. Are you getting this?
Yes, sir.
Yes.
Okay. So now this is done. Okay, so this is done. Okay. Now what we have to do is, this is our second order derivative. Okay, so we want the next. Okay, now again differentiate this. Differentiating about equation with respect to x, and we get so what will happen? Y3 is equal to minus 1 square, 2 factorial, you'll be having minus 3, and you'll be having a cube, and then we'll have ax plus b bracket raised to 4. Are you getting this term? What I did is that minus 3 will be there, and then one a will come, then minus 3 will become minus 4. So minus 4 I have taken in the denominator, so it will become plus 4. Okay, and now this 1 minus I will take here, and this 3 into 2 factorial. So minus I am collecting together, so this will become minus 1 cube. Then this is 3 into 2 factorial, so it will become 3 factorial, and we have a cube here, and this term is ax plus b bracket raised to 4. Are you getting this term?
Yes.
We got y3 is equal to minus 1 cube. This is 3 factorial, and you'll be having a cube upon. So you'll be having ax plus b bracket raised to 4. This is going to be the third derivative. So, are you able to generalize this, or we need some more derivative?
We can
Yes,
generalize.
sir, we can generalize.
We can
Yes.
generalize. Okay, that's good. Okay, so if you can generalize, okay, let us see what happens in general. Okay, in general, we have. Okay, so this is yn. Okay, now see what we have in the numerator. So when we consider the first derivative, we got minus 1. When we consider the second derivative, we got minus 1 square. When we consider the third derivative, we got minus 1 cube. When we consider the nth derivative, what we'll get is minus 1 raised to n. Is that okay?
Yes.
sir.
Yes, sir.
Okay, so when we consider the first derivative, we have 1 here, so 1 is same as 1 factorial. When we consider the second derivative, we got 2 factorial. When we consider the third derivative, we got 3 factorial. When we consider the nth derivative, what we'll get is
N factorial.
N factorial.
okay. Then when we consider the first derivative, we got a. For the second derivative, we got a square. For the third derivative, we got a cube. And hence, for the nth derivative, we'll have a raised to.
A raised to n.
Okay. Now see, for the first derivative, we got square. Okay, so square of this bracket. For the second derivative, we got cube of this bracket. For the third derivative, we got 4th power here. So that means if we consider the power of this bracket, then it is 1 more than the derivative. Okay, so it is 1 more than the derivative. So third derivative, and we are getting 4th power here. So if I want to find the nth derivative, then what I have, I'll be having ax plus b bracket raised to plus.
Plus 1.
Okay, so this is how we are able to get nth derivative of the reciprocal function. So we got the nth derivative of the algebraic function. We got the nth derivative of its reciprocal function. Now, what happens if we have logarithmic function? Okay, so suppose we have logarithmic function. So let y is equal to log of x plus b. So we have the logarithmic function. Then what we can do is we can differentiate. So differentiating y with respect to x, we get. Okay, so what will be having y1 is equal to. The derivative of logarithmic function is 1 upon x. So if I consider log of x, then it is going to be 1 upon x. But if it is a function, then we have to modify the formula as it will be 1 upon f of x and the derivative of the term f of x. Okay, so if we have the derivative of log, then it will be 1 upon x plus b and the derivative of x plus b. So can you Tell me what will be the derivative here?
A upon
A upon
A
A
upon
A
AX
upon
plus B.
X plus B.
Yes. So here we have A upon X plus B, right? So this is what we get. Okay. Now, this is the first derivative. Okay. So we got the first order derivative. Okay. Now, think of the next. So what we can do is, again, differentiate this. So differentiating for equation we get. So what we are able to get? Y2 is equal to A remains as it is, minus 1 into A upon AX plus B bracket square. Is that okay? Are you getting this?
Yes.
So what's happening here? This A is going to be constant, and you have 1 upon X plus B. And so we have to think of the derivative of 1 upon X plus B. So we got here minus 1 into A, and this is Ax plus B bracket square. So we can write this as y2 is equal to minus 1 into A square, and here we have this is Ax plus B bracket square. So this is the second order derivative that we have. Now again differentiate this. So what we can have is differentiating of equation we get. Okay, so what we'll be having here, y3 is equal to. Okay, so think of this derivative. Okay, so we want the third order derivative. We want to differentiate this function now. Okay, so we can have this is minus 1 minus 2 A square into A, and here we have Ax plus B bracket cube. Are you getting this term? So minus 1 A square remains as it is. These two in the numerator will be having minus 2. So minus 2 comes here, and the derivative of this term is going to be A. So we can write this as y3 is equal to. So can we write it as minus 1 square into 2 factorial into A cube upon Ax plus B bracket cube.
Yes, sir.
Are you getting this one?
Yes, sir.
Yes. So next question, can you generalize?
Yes, sir.
Okay. So have you got the sufficient steps to see the pattern, or have you got idea to identify the pattern? So if you can identify the pattern, that's okay. If you cannot identify the pattern, then we have to go for one more derivative. So we have to go on taking the derivative till we get the pattern exactly. Okay. So I hope you have got the pattern. So if you have got a pattern, then let us write it. Okay. Then this way we continue. In general, we have. Okay. So what we'll be having, we want to find the nth derivative. Now you can see for the first derivative, there was no minus term. For the second derivative, there was one minus term. For the third derivative, there were two minus terms. For nth derivative, how many minus terms will be there?
N
N
minus
minus
1.
1.
Yes. So we'll have minus 1 raised to n minus 1. Now, for the first derivative, there is no factorial. For the second derivative, there is 1 factorial. For the third derivative, there is 2 factorial. For nth derivative, what will have?
N minus 1 factorial.
N minus 1 factorial.
Correct. So we'll have n minus 1 factorial. So you got here n minus 1 factorial. then you'll be having a raised to n, and here we have ax plus b bracket raised to.
N.
So, are you getting this derivative?
Yes, sir.
Yes, sir.
Okay. So now here we have seen how to find the nth derivative of the product of exponential function and trigonometric function. How to find the nth derivative of the algebraic function. How to find the nth derivative of the logarithmic function, and how to find the nth derivative of the reciprocal function. So here, basically, we are done with all the different types of function. So we can find the nth derivative. Now, we'll try some examples. Okay, so let us try some examples. Okay, so we'll go with the example. Find nth derivative of y is equal to x plus 3 on x square minus 5x plus 6. So that's what we can do. This is the function that we want to find the nth derivative. Okay. Now see, for the solution. So always start with what you have. So y is equal to 2x plus 3 on x square minus 5x plus 6. And now you see, we have seen the formula for 1 upon ax plus b. Okay, so we have seen the formula for this term, which is a linear term actually. Okay, and here I have a quadratic term. Okay, so what to do is, the first thing is that, can I reduce this quadratic term to linear term? Okay, if I can reduce this quadratic term to linear term, then my problem will be easy. So I can take it to the linear and then solve in linear. But if this quadratic I am not able to reduce, okay, then what we have to do is, we have to find the first order derivative, we have to find the second order derivative, we have to find the third order derivative, and then we have to generalize. Okay, so remember one thing, whatever the formulas that we have seen up to 8, okay, first try to apply those formulas, and if any formula is not applicable, then find the few derivatives and try to generalize. Okay, so this is the thing that we need to understand. Now see the denominator. Okay, can you factorize it?
X minus 3x minus 2.
Yes, sir. X
Okay.
minus.
So you
X
can split the upper term also.
You can split the upper term also. Okay, we can split the upper term also, that's correct. Okay, but think of the denominator. Okay, so one thing you can do, you can use u upon v formula. Okay, and then try to find, but if you use u upon v formula, it will become more complicated. Okay, so think of the denominator and see that can we factorize it.
So
Yes, sir,
we can, we can put x minus 3 and x minus 2.
So we have the factors in the denominator as x minus 2 and x minus 3. Okay, so when we have the factors in the denominator as x minus 2 and x minus 3, then we can make it more simple by using the partial fractions. Okay, so we can make it more simple by using the partial fractions. Okay, so for the partial fractions, what you have to do is consider 2x plus 3 upon x minus 2 and x minus 3. So this is what we can do is a upon x minus 2 plus b upon x minus 3. So these are the linear terms. So that's why we can consider the singleton constants. Okay. And now we can write this as 2x plus 3 is equal to a into x minus 3 plus b into x minus 2. And now to find the value of a, we have to make its denominator 0. To find the value of b, we have to make its denominator 0. But making the denominator equal to 0 means what? If I consider x minus 2 is equal to 0, so that means x is equal to 2. And if I consider x minus 3 is equal to 0, so that means x is equal to 3. Okay. So if we put x is equal to 2 in this expression, then what will be having? This will be 4 plus 3. And here, this term is going to be 0, but this term will be minus a. So I can write a is equal to minus 7. Is that okay? Are you getting
Yes,
this?
sir.
Yes.
Yes,
Yes.
sir, yes.
Now put x is equal to 3. So this term will be 0. And hence this will be 6 plus 3.
9.
And this is going to be b. So we can have b is equal to 9. So is that okay?
Yes, sir.
Okay. So once we have the values of a and b, then we can write y. And hence we have y is equal to. So what will be y? I'm writing 9 x minus 3 minus 7 x minus 2. Is that okay? So b is a positive term, so that's why I'm taking it here. A is negative term, so that's why I'm writing it here. Nothing else. Okay. So there is nothing hard and fast. Yeah, Jason, you want to ask something?
No, so sorry, I forgot to lower the.
Okay. So please lower your hand then. Okay. Yes. So now we got y. Okay. And then we want the nth derivative of this y. So what we know is if y is equal to 1 upon ax plus b, okay, then we have proved that yn is equal to, what is yn? Minus 1 raised to n, n factorial, a raised to n, and this is
Ax plus
b
b whole raised to n plus 1.
to n plus 1, right? So this is the formula that we have, correct? Now what we can do is we can differentiate this y n times. Okay, so we can write directly differentiating y n times with respect to x k. So these are the reciprocal algebraic terms, so we can use directly this formula. And now for the first term, what is the value of a?
1
1.
The second term, what is the value of a?
minus
One.
3.
So we can have this as 9 into minus 1 raised to n into n factorial, and here we have x minus 3 bracket raised to n plus 1 minus, this will be 7 minus 1 raised to n into n factorial, and here we have x minus 2 bracket raised to n plus. So are you getting this nth derivative?
Yeah.
Yes, sir.
Yes,
sir.
Okay, good. Okay, so the formulae that we have proved earlier, we have to use it like this. Okay, so is there any doubt this example?
No,
So,
sir.
so
Sir, in exam also, we can take the reference of this formula and directly write the final answer.
Yes, you are supposed to do that.
Okay.
Okay, so if it is a formula, you have to find out the nth derivative, then you need to show all the steps. Okay, but if it is an example, then you can use formula. You can say that I'm using this formula as I mentioned the formula and then I used it. Okay, so always better that you mention what you are going to use.
Thank you, sir.
Okay,
So could you please show the slide again?
yes, surely. Yeah, so here I simplified this function. See, for this function, we don't have direct formula. Okay, so what I did is I simplified the function. And once we know that the simplest form of the function is this, and we have the formula which can be applied to this form of the function, so we can apply. Got it?
Sir, we can take also log na.
Log, log for what?
एग्जाम्पल में वो अगर लॉग भी लेते तो इजी बन जाता ना, या मतलब सेकंड स्टेप में जा हमने फैक्टराइजेशन किया वहाँ लॉग लिया तो हो जाता ना, लॉग
So
y
here,
इक्वल टू,
here you want to use log y.
हाँ हाँ तो भी हो जाता ना.
But then you will have the nth derivative of log y. We want to find the nth derivative of y, no?
हाँ, yes, yes.
You will be finding, if you take log, then you will be finding the nth derivative of log y, not y. Suppose, see, what is your query? I'll write it like that, then you will understand in a better way. Okay, so you are having log y, and we want to find the nth derivative of this log y, right? It will be like this. On the right hand side, it will be easy, but this, what will have, the first derivative will be 1 by y, and then you will be having by 1, right? Then again the derivative of this, again the derivative of this, you have to go to nth derivative of this. So what will be the nth derivative of this log y? It will be minus 1 raised to n. Okay. Then we are finding the derivative with respect to x, not with respect to y. That will be our problem again. So the what we have written is the easiest way. Got it?
Yes, sir. Got it.
Okay. So let us go for some another problem. Okay. So we'll go for the another example. Okay. Find the derivative of y is equal to cos x into cos 2x into cos of x. See, if you have two terms, it is easy. So we have three terms now. Okay. So we know the derivative of one term only, right? We know how to find out the derivative of cos of x plus b. But here we have cos of x into cos of 2x into cos of 3x. So whenever you have any function like this, then what we have to do is we have to express this product, okay, into the sum or difference. Okay, we have to express the product into sum or difference, and then we'll get one term, so we can apply the formula. Okay, so let us try to simplify this function. So let y is equal to cos x, cos of 2x, and cos of 3x. Okay, so what we know is, we know the formula that cos A cos B is equal to
So 2 cos A cos B.
so cos A cos B.
Sir, we can write
we can write cos x into cos 3x as cos 4x plus cos
Wait,
2x divided by 2.
just wait. Okay. So we have the formula again. This is equal to half of cos of a plus b plus cos of a minus b. Is that okay?
Yes, sir.
Yes,
Okay. Yes. Okay. Now what we have to do is we have to consider two terms at a time. Okay. So if we consider these two terms at a time, what we can have is y is equal to half of cos of x plus 2x plus cos of x minus 2x, and this is cos of 3x. Okay. So now simplify this. So we're having half of cos of 3x plus cos of minus x, and here we have cos of 3x. But what we know is cos of minus theta is same as cos theta. Okay, so that's what we have. Now let us simplify this. So we can have this is equal to half of cos of 3x plus cos of x, and this is cos of 3x. So we can write y is equal to half of cos square 3x plus cos of 3x into cos x. Is that okay? You're getting this?
Yes, sir.
Yes. Then what do we know? We have the another formula. So cos square theta is equal to half of 1 plus cos of 2 theta. Is that okay?
Yes, sir.
Yes, sir.
Okay. So we use this formula here. So half of, for this term, we'll be having half of 1 plus cos of 6x. Because theta is 3x here, so it will become 6x. Plus, for this, again we'll use this formula. So it will become half of, what we have here, cos of 3x plus x plus cos of 3x minus x. Okay, that's what we have. Now, simplify this. So we can have half of, this will be half of 1 plus cos of 6x plus half of cos of 4x plus cos of 2x. Okay, this half we can have common. So we'll be having 1 by 4. I can write this as 1 plus cos of 2x plus cos of 4x plus cos of 6x. So this is going to be y. See, what y was given to us, it was cos x into cos 2x into cos 3x, and then we simplified it to 1 by 4, 1 plus cos 2x plus cos 4x plus cos 6x. So is that okay? All of you are getting this term?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Yes. And now we can see we have only one term. So here we have one term, here we have one term, here we have one term. So we don't have any product mode. Okay. So what we can do is we can find the nth derivative of this, nth derivative of this, and nth derivative of this. So what we know, if y is equal to cos of ax plus b, then what we know is yn is equal to a raised to n cos of ax plus b plus n pi by 2. Is this formula correct?
Yes, sir.
Yes.
Yes, sir.
Okay. So we can use this formula. Now what happens to 1? Yeah, this formula is applicable to cos 2x, cos 4x, and cos 6x. What will happen to 1?
Zero.
It will become zero.
Zero.
At first
Zero,
Yes,
na?
because its first derivative will be 0 itself. Okay, so first derivative will go 0, and hence remaining all the derivatives will go 0. So when we consider the nth derivative of this term, all the derivatives will vanish for 1. Okay, and that's why we have to be careful. Okay, so what we can write? Differentiating y with respect to x n times we get. Okay, so what we are able to get? See, we'll be having yn is equal to 1 by 4 will be there. Okay, the derivative of this one will be 0. Here the value of a is going to be 2. Here the value of a is going to be 4. Here the value of a is going to be 6. So we can have 2 raised to n. Okay, and here what is the term you'll be having? Cos of 2x plus n pi by 2 plus you'll be having 4 raised to n, and this is cos of 4x plus n pi by 2, and this term 6 raised to n cos of 6x plus n pi by 2. So this will be the nth derivative of the given function. Okay, this will be the nth derivative of the. Okay. So we got this nth derivative. Is there any doubt?
No,
No,
sir.
sir.
No.
Yeah, Shruti.
Yes.
Okay. Okay, all of you got this 2 examples that we have solved.
Yes, sir.
Yes, sir.
Okay, okay, that's good. Okay, so we'll go for the another example. Okay, so let's go for the another example. Okay, suppose we have find nth derivative of y is equal to e raised to 2x cos x cos x cos 2x. So we have the function. Then we want to find the nth derivative of this function. Okay, so let's go for the nth derivative. Remember one thing, that first you have to simplify the function. Okay, then only think of the nth derivative. Directly don't think of the nth derivative. So what we have, let y is equal to e raised to 2x cos x cos of 2x. Now we know the formula for e raised to ax into cos of bx plus c. But we don't know the formula for the product, okay, of 3 functions. So that's why, as we did in the previous example, we express the product into sum or difference. Okay, so let us think of these 2 functions first. Okay, so what we can have is, this will be e raised to 2x, and we have half of cos of 3x plus cos x. Is that okay? Are you
Yes,
getting
sir.
this?
Yes, sir.
Okay,
Yes, sir.
good. So we have y is equal to half of e raised to 2x. This is cos x plus cos of 3x. So can we write this as y is equal to half of e raised to 2x into cos x plus e raised to 2x into cos of 3x. Can we write it like this?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, good. Then what we know is y is equal to e raised to ax into cos of ax plus c. Okay. Then what is yn? So yn is r raised to n e raised to ax cos of ax plus c plus n5, where now r is equal to square root of a square plus b square and phi is equal to tan inverse of b by a. Is that okay?
Yes, sir.
Yes, sir.
Yes, sir.
So can we apply this formula to find the nth derivative of the given term?
Yes, sir.
Yes, sir.
So we can
Sir, in
say
exam we can write directly the red line.
yes, you can write it directly by using this formula.
Yes.
Okay, but you should know the formula perfectly.
Yes, that's
So
important.
differentiating y with respect to x n times we get n. So what we are able to get is, see, yn is equal to 1/2. Okay, so please be careful. Okay, so here r will be different, phi will be different. Here r will be different, phi will be different because a is different and b is different. Here a is different and b is different. Okay, so that's why you will get two different phi and two different r. So what we'll be having here, r1 e raised to 2x cos of x plus n phi 1 plus here we will be having r1 raised to n, r2 raised to n, e raised to 2x cos of, and here we have 3x plus n phi. Are you getting this one?
Yes, sir.
Because for this term you will be having r1 phi 1, for this term you will be having r2 phi 2. Okay, now you have to write here where r1 is equal to square root of, what is r1? A square, so it is going to be 2 square plus 1 square.
Root 5.
Okay,
105.
phi 1 is equal to tan inverse
Tan
of
inverse 1 by 2. 1 by 2.
1 by 2. Okay, then you will be having phi r2 is equal to square root of, what you will have here, 2 square plus square,
3 square.
and phi 2
Tan
is
inverse
equal to tan inverse of
3 by 2.
3 by 2. So are you able to calculate the value of tan inverse of half?
It's 2 by 3.
So let it be. The thing is that if you don't get the perfect value, then let it be. Okay. Now we have to simplify this expression yn. Okay. And hence we write yn is equal to. So this will be half. So this is 5. Root of 5 means 5 raised to half. So you'll be having 5 raised to n by 2. Then e raised to 2x cos of x plus n times tan inverse of 1 by 2. Okay. Then plus. So what is the value of R2? Square root of 4 plus 9. So it is going to be 13 raised to n by 2. And this is e raised to 2x cos of 3x plus n times. So you get here tan inverse of, it is going to be 3 by 2. Okay. So this way we are able to get the nth derivative of the given function. Okay. So this way we are able to get the nth derivative of the function, and this is how we are supposed to use. So is there any doubt in this example?
No, sir.
No, sir.
Okay. So all of you got these examples.
Yes,
Yes,
sir.
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 Yes, that's good. Again, so you need to understand how to use the formula, and you need to understand how to derive the formula. Okay, so in first part, what we did is we derived the formula. Okay, and now what we did is we use the formula. Okay, so here you are able to find the nth derivative of any term now. Okay, what happens if you have the product, okay, of the algebraic function and trigonometric function? Okay, or what happens if you have two functions which are n time differentiable? Okay, so one part we have seen that e raised to ax into sine or cosine. Okay, what if we have u and v, both functions are differentiable n times, then how to find their derivative? Okay, so finding the derivative of the product, and the next thing is that how to find the n plus r derivative. Okay, so we need to go to n plus r derivative also. Okay,